Hi, I'm Chris with Sanderson Test Prep, and in this video we're going to take a look at adding and subtracting polynomials. So let's get to it. Here we see an example of the addition of two polynomials. So we have 4x squared plus 7x minus 8 plus the quantity 3x squared plus 5x minus 7. And we're going to start with an addition problem because adding polynomials is a little bit easier than subtracting. When you go to add polynomials, if everything is positive in front of the parentheses, so we don't have any negative signs out here in front of this parentheses, we have a positive in front of this parentheses, then that's good news because it simplifies things and allows us to just drop the parentheses. We can rewrite this as 4x squared plus 7x minus 8 plus 3x squared plus 5x minus 7. And then we are going to combine like terms. So if we start with the 4x squared, when combining like terms, what's considered a like term is anything that has the same variables to the same degrees. And that's important. We don't want to forget about the exponents. So you can't combine x to the first with x to the second with x to the third and so on. You can only combine everything that has an x to the first, everything that has an x to the second in their own groups. So here, the only other term with an x squared is a positive 3x squared. So we do 4x squared plus 3x squared, which gives us a 7x squared. We have a positive 7x and a positive 5x. And if you notice, it is helpful when you're first getting introduced to adding and subtracting polynomials. When looking for like terms, a good technique is to put one underline under each like term of a particular kind, and then double underline the next like term in the polynomial, and then triple underline, and so forth, so that you can differentiate. And so here we have a positive 7x and a positive 5x. That gives us a positive 12x. And negative 8 and negative 7 will give us a negative 15. And that's it. Now let's talk about a way that we could approach this problem and visually set it up differently, because many of you may have seen this in class. I want to make sure we introduce both methods. So let's say we take this same exact problem and see if we can delete our work there and set this up a little bit differently. So here, we can also write this as 4x squared plus 7x minus 8, and then put the second polynomial underneath, plus 3x squared plus 5x minus 7. And oops, I wrote 3x to the third. Hopefully some of you caught that and you were pointing it out on your own. If so, good eye. All right, so if we're adding these polynomials, then just like what we did before, think of each of these in parentheses, but if everything in front of the parentheses happens to be positive, we can drop the parentheses and rewrite it without. So here, 4x squared plus 7x minus 8, and then this will be a plus 3x squared, a plus 5x, and a minus 7. And that way our like terms are lined up one above another. We can add them together, and you'll see that we get the same result that we originally got. 7x squared plus 12x minus 15. So whether you prefer to set it up horizontally or vertically, it's not going to impact the solution you come up with, but for a lot of students, it's a little bit easier to keep track of the appropriate signs when setting it up one way versus the other. So make sure you get comfortable with whichever method you're going to be using in order to keep track of signs, because we'll see that once we introduce negatives, it does make things quite a bit more difficult. And it makes it a little bit easier to make a careless mistake. So here we have the same parentheses in terms of the contents within, but we have one big change. So that part's the same, but here's our big difference. Instead of a plus between these polynomials, we have a minus. And now we're going to be subtracting the polynomials. So let's take a look when we go to subtract these polynomials at how that's going to change things. And we'll do it both horizontally and vertically. So here, if we set it up horizontally to start, 4x squared plus 7x minus 8, that one works just like it did above, because out here we don't have a negative in front. It's still a positive polynomial. So if it's times positive 1, anything times 1 is itself, which is why we can just drop those parentheses. We don't have to worry about a polynomial with no coefficient in front of it and something that's positive. But this negative is going to act like a negative 1, right? 1 is our coefficient if we don't write it. So if we have a minus in front of the polynomial, we have to make sure that we remember to distribute that negative to each term within the polynomial. So when we go to remove the parentheses, we can remove those parentheses by using distribution. And here we would have a negative 3x squared, a negative 5x, and a positive 7. And so even though the two original polynomials were the same, by changing that plus to a minus, we'll see that we'll get quite a different result. Let's combine like terms. We have our x squared terms. We have the 4x squared, and we have the negative 3x squared. So 4 minus 3 is 1. So that would be 1x squared, which we can just write as x squared. Positive 7x and negative 5x will give us a positive 2x. Negative 8 and positive 7 will give us a negative 1. And that will be our final answer for this subtraction of polynomials. And let's run through this same calculation real quick if we take this and set it up horizontally, just to make sure we're visually comfortable doing it either way. So if we look at this horizontally, then we'll have our initial polynomials, or sorry, if we look at this vertically, I think I said horizontal, but we have our initial polynomials, the 3x squared plus 5x minus 7. But here we have a negative in front. We're subtracting. So when we go to rewrite these, we have to make sure that for the polynomial on top, we don't have to worry because it's positive. But for the polynomial that we're subtracting, we have to make sure that we distribute to each term within the polynomial, just like we did up at the top. So here this will be a negative 3x squared. When you multiply the negative 1 times a positive 5, we get minus 5x. Negative times negative gives us a positive 7. And then we can combine like terms, and you'll see that we get the same solution, x squared plus 2x minus 1. So those are two ways that we can set up polynomials when we have either addition or subtraction. You can set it up horizontally, you can set it up vertically. It's not going to make a difference, but the most important part for us to make sure that we understand is that if we have that negative in front of a polynomial, then we're going to have to distribute to every term within that polynomial. It's going to change the sign of everything and give us quite a different answer. Let's try one more slightly tougher example below. So here, what can we do with this first polynomial? So if you said something like drop the parentheses, that's absolutely correct. Then with the negative, what do we have to do here? If you said distribute, that's absolutely correct. From there, we can combine like terms. 3x squared minus 6x squared would be a negative 3x squared. Positive 12x and negative 15x would be a minus 3x. Positive 5 and positive 11 will be a positive 16. And that's our final answer there. And one other note to make about the way that we underline the like terms. The other advantage in doing that is that as you get to more and more complex polynomials, what you'll find is that if you underline each term as you're combining like terms, when you have really, really long expressions and you have polynomials with 5, 6, 7, 8 terms each, it'll ensure that you don't miss any terms. Sometimes the polynomials will be written out of order in terms of the degrees, or there might be a missing degree value in there, so it can get quite complex, and we'll do a few examples of those in our other videos. If you have any questions or comments, drop them in the comments section below, and thanks for watching.